Want to go ahead and introduce yourself?
Sure. Thank you, Julie. Again, Jesus Diaz here. I'm working currently for IGNW, CDW company, as a lead consultant and head of data solutions. So I've been working around IT software development for 20 plus years. I started in my teens. No, I'm just kidding.
That's what I say.
That's what Julie said. But I started my professional life as a software engineer, and then about 10 years ago, got more into management and running my own shows and doing my own companies. And I've done a couple of those, but last one was really aligned with Google Cloud and data products. So that's where I found my latest passion or call, if you will. And I've been working around data and analytics since then. Google Cloud is dear to my heart because it's where I've spent last 5 years of my professional life, and doing everything from development, data and analytics, training, a lot of fun stuff. So I'm really excited about Great Data Minds having me today and share some of those experiences. I like to say battle scars, like from the field, from a number of implementations. So happy to share some of my experiences around GCP.
Yep. So I'm Julie Burrows. I'm one of the founders and an advisor at Great Data Minds. I met you. We met about 5 years ago in San Francisco at a Google partner event, and had a beer that night. And then over the years, we've worked together in some capacity or another. But IGNW is one of our go-to partners for resources, and we love working with Jesus and his teams. Just a little note there that he didn't mention, but all of his resources are SAFe certified. So they produce, they are really producing great stuff. So, okay, let's do this. Show us, we do have a couple of continuous education programs coming up around GCP. This is based on requests from our community out there. Jesus is going to do 2 events for us. Number 1 is a 1 day. So it's for a broader audience. So if you guys are looking at doing GCP out there, it's not just your practitioners that need to learn it, but you need to, make sure that the person managing the project understands GCP and the benefits, even bringing in your more technical savvy business people. We do this a lot for organizations. It's a 1 day workshop. We can do it on site, but we are going to take it public, and it will be on the 26th and the 28th of April. So we're taking that 1 day class and breaking it up because it is virtual. But we're also having a 3 day class. Jesus wouldn't let us break it up for you. If you're interested, it is for practitioners. Jesus will be running it. We believe in the power of instructor-led training for collaboration, clarification, get to know other people, which we need a little bit more of these days. And so it will be on May 18th, 19th, and 20th. And I'm supposed to have a drum roll and a slide to support this somewhere. There we go.
I'm just sharing my screen.
So anyway, you can find these out on our event site. And here comes the fire truck right by my place. So you guys, sorry about that. Anyway, so join us if you can. So let's get this party started. What do you say, Jesus?
Yeah, let's get to it. Let's get to it. I forgot 2 things when I did my introduction. The first one is that I'm also a Great Data Minds advisor. So we've been working even before I started with IGNW. And the second one, it's around GCP, that I'm dual certified. So I'm certified data architect and also certified data engineer. So a lot of the things that we do in this training are part of the certification program. But we don't focus just on the material that it's on the certification. Like if you go to Coursera or Pearl side, we focus also on bringing live experiences from the projects and products that we've used. We're going to tell you also, the gotchas using those products that typically they're not advertised. And as Julie said, there's something about interacting with your trainer and just being able to ask questions. I think that's really valuable
Yeah,
from the training perspective.
very much agree. All right, here we go on the party. Ready?
Okay.
Everyone always says, why GCP? Why are you guys so passionate about GCP?
Yep.
So you had some pretty good stuff you were sharing with me the other day. I've got a couple things to add, but I'll let you get started.
Yeah, and I don't want to fall into the kind of like the the selling speech, but the one thing that about 5 years ago when I started looking for a good cloud vendor to build my consulting practice around, the one thing that struck me when I was looking around from Google is that basically when you work with Google Cloud, you're working with the same infrastructure that the company uses to run their products. And everyone is familiar with Google products, right? Gmail, Maps, YouTube, the search. Uh, they have outages here and there, but given the size and the amount of consumers that they have at a global scale, it's amazing how resilient and how well thought are these products. So the infrastructure that powers Google Cloud, it's the same infrastructure that powers Gmail, Maps, YouTube, and search. And you might I, I, once you work enough with Google, you start identifying. So this product is being used for Gmail. This product is being used for YouTube, things like that. That's the one thing that for me is the most remarkable. So it's a company that have built. I think they have like 3 or 5 trillion, like products that have more than a trillion users, something like that. I don't quote me on that, but it's massive, the adoption, and they use Google Cloud just to power everything. I think they were just late to find a commercial way to commercialize their cloud because they were so busy just running their core business. That's kind of like my bigger take.
One thing that I see, Jesus, is the passion for innovation these guys have. I mean, if you're innovating, some of the top organizations in the country or, have at least some workloads, a lot of workloads over there on GCP, just the innovative mindset that comes out of their teams.
And what I'll say with that, this is particularly relevant for data and analytics, because if you come to think, their first product, which was search, it's all about indexing, searching, organizing information. So they have to come up with their own tools and their own products and services to address their own internal issues. And I will cover a little bit more along the presentation when we present the GCP or Google contributions to the open source and all the white papers that come out of Google and Google research. But I think that's one thing that worth singling out.
They also, their commitment to society, I think, is a great one. Their green programs. And also, we are working with the healthcare API. So their investment in healthcare is huge. They had the first healthcare API out there. And I know that there's over 100 healthcare organizations on it now and growing all the time.
Yep. And from the commercial standpoint, Google is really betting on GCP to be their next thing. So I think it's the next evolution, the next company evolution. There's a couple of slides here. Like for example, this one is a little bit outdated. I wish I had the data for last year, but in 2019 they put 13 billion just building data centers around the US. And they have an infrastructure that is second to none. They own, I believe, 70% of the the optical fiber that is laid in the world. It's amazing. It's amazing from the infrastructure standpoint. I don't think there's any other company doing what they do out there. Another big thing, and again, I don't want to make this a big sales pitch, but Google, it's been committed to the open source ecosystem from day one. And all these are products that they open source. You have Kubernetes, you have Anthos, you have Istio, TensorFlow, a Flutter, Angular. You call it. It's a big contribution to open source. And what that means for their cloud is that everything they run on the cloud, or I shouldn't say everything, but a lot of the products that run on the cloud are based on the open source versions, and
Yep.
they don't do what other clouds do, that put that proprietary layer on top of it, so they lock you in, meaning that it's pretty vanilla. There's always going to be some managed services advantages to using, for example, GKE on top of plain vanilla Kubernetes, but it's fairly straightforward to take, for example, a Kubernetes deployment from Google Cloud and take it on-prem. It's fairly simple to take an Apache Beam pipeline, which is cloud, which is the Dataflow. I'm sorry, Dataflow, which is based on an Apache Beam. It's pretty simple to take an Apache Beam or a Dataflow pipeline and move it to something like running on-prem using Flink or Spark. So again, they really bet on not locking you in on their ecosystem, and having you work with Google Cloud because it's the best cloud to run your workloads, not because it's the cloud that is locking you in. So I think that's an interesting perspective as well when you're choosing your cloud vendor.
Hey, Stacey, we have a large healthcare organization, probably one of the biggest top 10 companies here in Denver. And they chose GCP just because it also, the data science group chose it, first of all, because of the TensorFlow investment. And then all of a sudden, the big data workloads are coming over and application, et cetera. So a lot of people are looking at those AI/ML solutions from Google as being a top solution out there. Thus, starting to move in that direction.
Yep. I think that's a very good point. And there are other things. Like Google's commitment to sustainability and be carbon neutral. But as I mentioned, cloud technology has been forever part of what Google is. And all of the data centers that they put together just to run their core businesses. What have enabled it's an incredible infrastructure, incredibly resilient infrastructure, and incredibly resilient products and offerings that now you can use to build your applications.
All right. So
do you want to start talking about data?
I do want you to start talking about data. I'm not going to talk anything technical, but
yeah,
I'm going to listen.
Well, the first thing I want to tell everyone is the way we organize this is we're going to cover first we're going to have a quick overview on some of the data products around Google Cloud, and again, I want to make this a conversation. So if you have any question, please put it on chat, and Julie, help me with that because I'm not monitoring the chat. But
gotcha, brother.
I want to make this more of a conversation. So we're going to cover briefly some of the data products out there for Google. We're going to cover a little bit more about the options for data management and data processing. And then I want to focus, because there's, as Julie said, there are so many products and so many different things that we could be talking about today. I want to focus on what Julie and I think we joke around what we call the crown jewel of GCP when it comes to data and analytics, which is Bigquery. So we want to focus more on Bigquery, and the reason to do that is, personally, I think there's no other product out there like Bigquery. Maybe Snowflake. There's another one now that it's coming on the serverless data warehousing world, but I think it's by far a big differentiator from Google Cloud. And strategically, what they've been doing is they've been building the whole data ecosystem around Bigquery. So I think understanding how Bigquery works and how you can leverage BigQuery, it's a big part of defining or adapting uh, Google Cloud as a data and analytics platform. So we're going to cover that in three sections. The first one is going to be a very quick introduction to BigQuery, what BigQuery is, what BigQuery is not from the functional standpoint. Then we're going to get a little more deep into how do you work with BigQuery, how do you load data into BigQuery, how do you consume data from BigQuery. And then the third section that I don't know if we're going to have time to get to it, it's advanced BigQuery. So we're going to talk about things like slot management, how BigQuery actually process queries behind the scenes. How do you optimize your queries for speed, but also for cost concerns? And we're going to see how far we can get with this. But again, I want to make this a conversation. Any questions that you have along the way, just feel free to put it on the chat, and then Julie is going to be your voice. Okay.
Mm-hmm.
Okay. So I like this slide, and it's a little bit dated. I think it's been more than 15 years, more like 18 years. Google itself has 22 years of being around. But I like this slide because it captures very well how Google's been innovating around data analytics, how those innovations have been open source or have originated products or complete ecosystems on the based on open source products, but also on the flip side, how the same products that have fueled a lot of these open source and ecosystems have been internalized and are now part of the Google Cloud family of products, right? So if we start from the beginning of this chart, back in 2002, Google come out with a seminal paper, which was the Google file systems. And if you've been following Google, not just from Google Cloud standpoint, but from the research standpoint, you remember one of the value propositions from Google was actually how do we run our indexing and our search engines on commodity hardware. So they didn't want to come out with these supercomputers to run search and indexing. So they started engineering their system in a way that they could build on commodity hardware, very cheap hardware, and they will build resiliency based on redundancy and communication. So the first paper was Google File System, was this massively distributed file system in which thousands of computers could participate, and there was all this shuffle going around. And pretty soon after that, they come up with the concept of map reduce over this file system. So two simple operations: map data, map large amount of data based on a function, and then the result of those map reduce it to obtain another subset of data. So as you will know, MapReduce is the foundation of Hadoop, which is a product that Yahoo picked up, and then they open source, and Hadoop originated a huge ecosystem around it. Just like, it made popular the term big data. And for a long time, Hadoop was synonymous of big data. But again, Google didn't stop there. So Google kept working on things like Bigtable that then originated Apache HBase. But if you tag these things, kind of like I want to make sure that we put this in perspective with what you'll see on the Google Cloud product right now. So Bigtable is ultimately, Bigtable. So you can run the same Bigtable, 100% compatible with Apache 8base if you use the Bigtable product in Google Cloud. And likewise, when you see Dremel, which is ultimately Apache Drill, that's ultimately BigQuery. It's the same concept, the concept of having a decoupled system in which one area of the system will handle the storage and the other part of the system will handle the processing. And we'll get more into the details of that. Again, moving forward, you have things like Flume, Millwheel, and TensorFlow. Those things, all those products are Apache Beam, TensorFlow, and are the foundation of the Google Cloud product. So you can think of a lot of the Google Cloud products as managed versions of their open source cousins. And as I keep mentioning, more often than not, they're 100% backward compatible, meaning that if you're using something like Bigtable and you don't like the performance or the cost that you're getting from Google, then you can spin your own Apache HBase system, and all of your systems are going to be able to communicate with that seamlessly. From the data analytics databases and storage standpoint, I wanted to briefly cover in a more formal way the products that you'll find around Google Cloud. Again, we mentioned a couple of times BigQuery, but we also have Dataflow. I just mentioned Dataflow. It's the next evolution for big data. If you're familiar with Hadoop and the Hadoop ecosystem, one of the big limitations from Hadoop was that it was oriented for batch processing. It couldn't handle very well stream processing. And then there was a lot of attempts to address those shortcuts like Storm, and then with the coming of the Spark ecosystem, there were a lot of things around that. But Cloud Dataflow, which is Apache Beam underneath, it's a natural evolution from the big data processing, and it defines Apache Beam defines a programming model that you can run on top of multiple runners and executions, Cloud Dataflow being one. But ultimately, one of the strengths of this model is that it allows you to process streaming and batch processing. It allows you to capture streaming and batch processing in just one programming model, and you can combine batch processing with the stream processing. It handles things like windowing, watermark, a lot of interesting concepts. So Cloud Dataflow and Apache Beam is one of my favorite products, so I can talk a lot about it. Cloud Data Proc, think of Cloud Data Proc as managed Hadoop. So that's pretty much the EMR from AWS. And I think Azure also have something, a similar concept. I think it's called Azure EMR. But Cloud Data Proc is ultimately managed Hadoop with a couple of big distinctions. So because if you use something like Google Cloud Storage, it can be used as a replacement of Hadoop file system, HFS. So you can use Cloud Data Proc in very interesting ways. Like, for example, you invert the pattern, and instead of having jobs competing for resources, you pretty much you create one cluster per job, ephemeral clusters, and then you just do the processing there, and the storage you do it in Cloud Storage. So again, very interesting pattern. If you look at what Google Cloud advises, the advice is more like a stopgap if you want to migrate your Hadoop clusters into Google Cloud, but it's still a very, very solid product. Cloud Dataprep is a product developed by a third-party company, Trifacta. So it's more about data prepping and managing, transforming data, cleansing data, wrangling data. A great visual interface for its purpose. I think it's a great tool. Ultimately, it's been seen as a way to load data into BigQuery or just to process large amount of files. And under the hood, it uses actually Cloud Dataflow to do the orchestration. Cloud Data Catalog, that's one of my favorite Google Cloud products. And I know I say that a lot, but I think it's really powerful, the integration that they achieve with Cloud Data Catalog. So it's ultimately metadata management and policies, data access policies, but it's fully integrated with BigQuery, it's fully integrated with PubSub, it's fully integrated with cloud storage. So you have one place in which you can add metadata to your cloud data assets, catalog, define access policies, so you restrict access to certain assets based on cloud identity roles. Really powerful product and relatively new. I think they announced it like last year or the year before.
We get a lot of questions on the, data catalogs are so hot right now, Jesus.
Okay.
I'm assuming with the Google Data Catalog, you're right, it was just recently announced that it's only cataloging the data that resides within GCP, or does it expand beyond yet?
You can deploy your agents either on-prem or other clouds, and then there's a REST API. That's a cool thing from GCP that I want to go on a limb, but I want to say that 99% of all of the things that you can do on the console, on the cloud console, you can also do it through a REST API. So you can deploy your own agents, so they catalog things like, for example, integration with AWS Glue or on-prem, or but ultimately you can do your own integration and just hit the REST API. Again, and we should have mentioned this from the get-go. One of the key differentiator from Google Cloud is that they understood that in order to gain market share, they have to play well with other clouds. So they were coming in third. They really want to be, they really want to be second or first on the cloud ecosystem. But they understood pretty early that they have to play well with other clouds in order to compete and to drive adoption. So you will see a lot of their efforts, not just providing an open ecosystem, but playing well with AWS and Azure. And it comes to mind something that I heard about 2 years ago at a reflection on the Partner Summit. And it really resonated with what I've seen around Google Cloud, is that they wanted to be the best cloud to run open source software. Okay. Any other questions, Julie, on the chat that we should?
We got a couple. Elizabeth asked, getting started with analytics. I was wondering if most workplaces are using GCP, as I'm still learning, and is there more learning opportunities for GCP?
There's a lot of learning opportunities out there. I think from the training perspective, you have some of the trainings that we provide, but we also have Coursera material. Google Cloud made a big investment on training and certification. So I believe there are like 5 or 6 certifications out there right now, and they are sought after in the market. So
Yeah.
getting one of those certifications can really back up your career.
Yep. Go ahead and put that on LinkedIn and see what happens to you. Put your certs out there.
Yeah.
And then, so Elizabeth, I would say GCP is in third place right now, but because of some of the things that we discussed in the beginning, such as, people turning to Google for AI, ML, we're seeing a lot more market share year by year. So Raj says, hey, Jesus, can you shed some light on observability options, if any, on GCP through data lineage?
I don't think they have a data lineage per se product. You can accomplish a lot of those things with the cloud data catalog, because you can add metadata from your ETL, ELT, even from the data load, and then just provide traceability all the way to the to BigQuery or where you are. What I've done from that standpoint is it's use third-party tools like dbt and Dataform, if you truly want to establish that the strong lineage on your data. And if you're doing something, if you're doing more ML/AI, try something like Pachyderm. So Platform AI does a very good job as well, just building your pipelines, and they're all based in Qflow and TensorFlow TFX. So there are good technologies out there. I don't think they have that integrated with Cloud Data Catalog right now as a managed service.
Raj said, thanks, but they are complex to manage and maintain at scale.
GCP?
I believe you're talking about the additional platforms, right, Raj? And we have everyone muted. Observability. So.
Yep. Yeah. It's tricky, and then there's also the question about the ROI, right? So how do you sell that to the business? Yeah. Again, I don't think we need to mention all of these, but on the databases, there's a couple of databases that stand out. If you look closely, BigQuery is listed on the data analytics and not on the databases because I think it's more. It's when you think in terms of a traditional database, BigQuery is a beast in itself. So, but I already mentioned Bigtable. If you're doing anything transactional, time series, BigQuery, Bigtable, it's your go-to product. Data store that's S3, just like blob storage. You have the Redis memcache equivalent in Cloud Memory Store, Cloud SQL, which is your traditional transactional SQLs. Managed, think of it as just managed SQL databases, and Google Cloud supports right now Postgres, MySQL, and SQL Server. I believe those are the 4 that it supports. Cloud Spanner, I think it's a very cool product, and it's one of the, I think, underrated, most underrated products out there. I wish to see more companies using Cloud Spanner, but since companies are not catching up, Google is actually using Cloud Spanner to build a lot of the their managed products. And Julie mentioned Cloud Healthcare API. Actually, Healthcare API is built on top of Cloud Spanner, and the Cloud Data Catalog is also built on top of Cloud Spanner. So it's a transactional database that scales horizontally. Pretty impressive. If you want to check one product in this list, check Cloud Spanner. It's pretty amazing. And then more traditional storage, your usual storage like persistent disk, Cloud File Store, Cloud Storage. That's more like for file and blob storage. But again, a lot of products. There's one product that I'm not including here that I believe is pretty interesting from the analytics standpoint, and that one is Looker. For those of you that follow the BI space, Looker got acquired by Google, I want to say about a year or so ago, and it's been fully integrated now with Google Cloud. I think it's going to be it's a great addition and fully aligned with a lot of the things that the Google Cloud's been doing in that space.
Hey, C's little time check. You got 20 minutes.
Yeah. Okay. So I think if we were to put this from the data or data processing lifecycle, this is where the products will fit in. So we have on the ingest capture, we could do things using Google Cloud, App Engine, which is, again, it's a product that was the first product that Google Cloud came up with. And there's a little company out there called Snapchat or Snap that runs its own mobile application using Google App Engine. So again, another interesting product in the Google Cloud arsenal. But you have, you can ingest data using the App Engine, Google Analytics Premium already integrated, pops up, monitoring, and then you will process it. I mentioned it using Cloud Dataflow. the beauty for Cloud Dataflow is that you can combine batch and stream analytics, or you can use Dataprep if you're more of a Hadoop shop. Store doesn't have to be either or. You can store part of the data into BigQuery or part of the data into Bigtable or cloud storage. And then for analyzing, you can like go back. BigQuery is a great tool to just run analytics, just run SQL-based analytics. And they also support machine learning, running machine learning models using BigQuery ML. But you can always use something like Dataflow or Dataprop just to pull data out of BigQuery and do your own analytics. And visualization, I mentioned Looker, but there's a lot of third-party tools like Tableau, Click,
Come on.
ThoughtSpot.
Yeah.
ThoughtSpot. I know Julie's a fan. But there's virtually every major analytic tool has BigQuery as a data source. So it's a safe bet from the analytics standpoint. Yeah, the cool thing from running analytics backed up by BigQuery is that products like BigQuery make ELT popular. Extract, load, and then transform, as opposed to extract, transform, and load, because it's so cheap just to use BigQuery to process data instead of just like pulling data into your BI tool. That it makes it really easy and simple just to visualize data using a very lightweight BI tool. Okay. Again, I'll breeze through these, but it's there's certain aspects of your data workloads that you should look at when you're choosing one of these databases. And Julia, are we gonna make the presentation available after the?
Well, we're videoing or we're recording this. Excuse me. So
okay.
Yeah.
So I recommend getting back to this slide and look where to use BigQuery, where to use Cloud Spanner, where to use Cloud SQL. I think this is kind of like a nice cheat sheet for when you're choosing where to put your data in BigQuery. And yeah, I know we're a little bit short on time, so I want to breeze through some of these things. So again, a couple of things about BigQuery. So BigQuery, it's fully serverless. It's fully managed, so you don't need to do anything. You don't need to revision one server, and it's that simple in the sense that it's just like running SQL queries. So you load your data. Of course, your data has to conform to some tabular schema, but even BigQuery can infer the schema from your data. And it's just as simple as start running SQL queries on top of your data. It's secure because you control security at the data set level, at the table level, and more recently at the row and column level. So it's very secure, and it's pretty cheap, all things considered. So, and we'll see if we can get to kind of like cost saving and how costs work, because but it's for. Let me say that if you have gigabytes of data in BigQuery, it's going to cost you cents just to store and process it monthly. So
I remember years ago, Jesus, we did our first what we call Prove It, which is a POC with BigQuery, and we were working with an organization that had Oracle products on-prem, and we took a 75-minute query to 1.6 seconds. And I met with the CFO that was over the weekend, and I met with him the following week, and he goes, yeah, and it cost me $14.
Yeah,
it's like,
yeah, it's ridiculous how much you can do with this. So and this is an example that I actually want to show you. I want to run this query real time, but I want to stop for a moment here and just kind of like dissect or go over what this query does. So BigQuery has a lot of what they call public data sets, which is just think of it as databases that you can use for free, just to try it out things with BigQuery. And this particular data set is called Wikipedia Benchmark and has 100 billion pages of Wikipedia. And what this query does is actually it queries, it does a regular expression mesh on those 100 billion pages, and then it groups the matches by number of views of those pages, and then it and by language as well. So which language the page is in. So if you look at what it does, is that it reads around 1 terabytes of compressed data and decompresses in about 4 terabytes, execute 100 billion regular expressions, and we all know that regular expressions are pretty expensive in terms of processing power. And then it shuffles data. It shuffles about short of 1.5 terabytes of data across the networks of workers. So the GIF actually shows its query executing in about 27 seconds. I'm gonna run it here, and when I run it, I'm gonna do a couple of things. And by the way, this is the BigQuery interface. It's a new UI. If you look at here, this is kind of like the old UI, but they revamped the UI about 2 years ago. So I'll do a couple of things here. I'll get into query things, and I won't use catch results. And then we're gonna run the query. And when I run it, it actually, it took around 40 seconds to run last time. But again, it's pretty impressive, all things considered, right? Think of the power that this will give your analysts, or it will give you as analysts, to just crunch a lot of data.
So, hey, so there is a caveat. I mean, one of the reasons why we see Snowflake being so popular and a lot of our clients moving in that direction, most of them, by the way, not being Google, is that you can take those engineered models, data models that you've been supporting all these years, and you can lift them up, start using them almost immediately. But really and truly with BigQuery, you've got to flatten those files out.
Yeah, and we're going to cover what BigQuery is and what is not. So I think BigQuery is deceivingly looks like a transactional or traditional relational database, and that is not what it is. So yeah, definitely there are a couple of things you should take into account when you're moving your data to BigQuery. So BigQuery runs. It completed in 16 seconds this time, and this is not using catch results. So if I go here and I actually say, use catch results, right? Yeah, this runs into 11 seconds. So I think, from using catch to not using catch, that's pretty impressive, right? Again, just to Julie's point, BigQuery is not a transactional database, so you shouldn't think of BigQuery as a relational database with tables and foreign keys and all those things. So oftentimes it's better just to have all the information in just one table, either denormalized or using things like nested fields or structures within the table. So BigQuery is not an operational data store, so don't try to do single updates and single inserts. It's more meant for bulk uploads or bulk processing. And BigQuery is not an on-prem solution or appliance, although they're coming out with BigQuery Omni, which is like super cool. The idea is that you can run you can run BigQuery in other clouds. Like you can have a part of BigQuery running in AWS. You can have part of BigQuery running on your own Azure or on-prem. And then when you're querying data, you can also query data that is in Azure or AWS or on-prem. And what BigQuery does is that it also works as an orchestration for those queries. So data that exists in Azure is going to be processed by that Azure cluster, and then only the results are going to get pulled together and kind of like cross-reference. So I think that's a very important update to to keep an eye on. It's called BigQuery Omni, and I don't think it's out of the public private alpha right now. As I mentioned, BigQuery, it does things differently. So they don't store data. Records of data are not stored sequentially. Typically, what you would do on a relational database, but each column is stored separately, and that's why there are other considerations when you're looking at it. So under the scene, it's more like a big data product. Like it's shuffling the data, it's moving data around, and that's a big difference. And data, it's kept separated from processing. So you have your data shards, and then you have your processing engine, which is somehow similar to what the approach of other modern data warehouses like Snowflake. Again, just reiterating what we said, interactive analysis for petabytes of information, standard SQL 2011 compatibility on the query, a lot of options to ingest, transform, load data into BigQuery, nested fields, repeated fields. You can use user-defined functions, JavaScript user-defined functions, and it's pretty cheap. Kind of like their model is, you get charged by the amount of data that you have stored in BigQuery, and then you get charged by the amount of data that you process in BigQuery. But just to give you an idea, any data that it's been in BigQuery 90 days or longer, it costs you the same to have it in BigQuery that to have it on the cloud storage, which is the cheapest storage option for BigQuery for Google Cloud. And we mentioned public data sets. These are data sets that are either provided by these organizations or put it together by Looker with the support of these organizations. And I want to show actually how that looks in real life. So if you come in here and you said explore public data sets. So this is the list of all of the data sets that you can access as part of BigQuery. Some of these data sets are updated daily or monthly, but you see you have, probably you have close to 100 data sets. You can filter by advertising. Of course, I mean, now COVID, it's becoming, a lot of organizations are producing information about COVID-19. So you have a lot of data here. You also have information about bitcoins and cryptocurrency. If you want to do some analysis in that area, again, a lot of data sets that you can just go and play around. And by the way, the query that I run actually, it was based on one of those data sets. Okay, I know we are kind of like running a little bit tight of time. So Julie, do we have any questions on the chat that we want to address right now?
No more questions, but we did want to give some advice to those that are looking at going to GCP before we end our event today. So if you're going to look at GCP as an option, we recommend you do a POV. Joseph, I'll get to your question here in a minute. And we call ours Prove It, but let me tell you why our approach works and why you should consider it, whether you do it yourself or work with us or a Google partner to do it. Number one is it's a dip your toe in the water. So very low cost. You can take the most valuable insight in your organization. That's what we recommend. And you can apply a couple sources and then, use your reporting tool, of course, and you can develop what we refer to as a POV. But more importantly, we deliver those to our clients and they're, they can build off of them or, use, once again, a Google partner to help them build off of them. But more importantly, this goes back to the human side of things. You need to tell your organization, your executives, and more importantly, the people that have the budget, your successes. So you should always deliver, scream from the top of the mountain, as we say, the fact that you were able to do this We recently just finished a POV with one of our clients, and we did, Jesus and his team and our team did in 12 weeks what they couldn't do in 4 years. And I'm not kidding you. And over again, we have case studies that if anyone wants to go through them, we can definitely schedule some time and we can talk you through a lot of great use cases or case studies, shall I say, around Google. But whatever you do, if you do dip your toe in the water, make sure that you have what we refer to as an executive readout. And that includes the old way of doing it, the new way of doing it, the differences in costs, so ROI, and what the future looks like. I think people do great work sometimes and don't scream from the top of the mountains, but always consider an executive readout. So our prove it is we deliver an instance based on a critical insight that you want to build. And the other 50% is we deliver an executive readout workshop for everyone in your organization. So getting started, that's key. Joseph asked, Firestore or Data Store? And I think,
well, there are different products. So you have file store, you have Fire Store, and then you have Data Store. So there are three different products. So File Store, think of it more as a file share. So you should have a file share on your organization. Whereas Firestore and Data Store are more NoSQL options. Actually, Firestore it's a superset of Data Store. And if anyone have developed mobile applications, you should be familiar with Firebase. So Firebase is another company that Google bought. That it's a mobile backend as a service, and it provides communication with mobile devices, message passing, push notifications, and the database that come with that framework was actually Firestore. And now Firestore is becoming the de facto a NoSQL managed database for Google Cloud products.
and Joseph's response was, no, I thought Firestore was to replace Data Store. No.
No. It's yeah, no. If file store, think of it more as a shared drive. Yeah.
Okay, cool. I think for right now, that's all the questions. I wanted to thank everyone for joining us today. Please join us. A couple of events coming up that you should know about. We went through the 2 workshops that are coming up. We've got an AI ML event coming up, get out of the POC funk. Please join us for that one. And exciting is the Technology Matters Marathon, which is on March 10th. And you can join us all day long. And there are those that do, by the way. And we'll be looking at some of the top technologies out there with our partners. So we're really excited about that. So the Technology Matters Marathon on March 10th. So I just sent you the link to our events page. Join us there. Look in a couple of days over on under Technology Matters, and you'll see this interview if you want to share it with your colleagues. So thank you so much, Jesus, as always. It was wonderful talking to you. I think we talk a lot, but you always amaze me with your knowledge of this stuff. So thanks for showing us what you know and your passion.
Yeah, thank you for having me. It's my pleasure. Again, technology, it's the one thing that I enjoy. I don't think it's a job. I think it's it's my call. And happy to jump into any conversation, any just like again, helping people explore Google Cloud provides me with great joy, because I think it's a great company that is doing a lot of innovation, and they have great products. So I'm happy to do this all day long.
Right. And I'm leaving you with my email. So if you want to jump on a call with Jesus and explore any of the topics that he went through today, or any of the technologies, I should say, please, hit me on an email and I'll round him up. I've got him on Slack. So, Jesus, thank you so much.
Yep. Thank you. Have a great day.
Take care, everyone. Thanks for joining us.